supposed to state whether or not the function is continuous at the value of where the rule for the function changes. If continuous, state the 3 criteria of continuity. If not, state why. Big hint. A lot of us had copied it down wrong or made an arithmetic mistake in the middle. Okay, those were the 2 biggest things I saw with this one. And this was a double problem on the test. Problem 1, you had to find the limits. Problem 2, you had to discuss continuity. And I had a lot of people say that the limits weren't equal because they made a mistake copying it down. And that was really heartbreaking to see that, because you understood what to do, but I couldn't see that you could finish the problem. It is my intent on this problem is for it to be continuous. Okay, so know that going into the test. If it doesn't coming out continuous and you've double and triple checked to make sure you wrote it down right, then you need to, message me in the chat on GoGuardian and tell me, hey, Mrs. Ballard, I think you messed up, and I will double check. I told the group this morning that when you guys are taking a test, it always seems like a good day for me to, I'll get caught up on grades. It never happens because I'm always busy answering questions during the test, or just monitoring what's going on, or if something goes wrong with the question, I'm going back and I'm double checking that question, okay? For 20 years, I've told myself I'm gonna get stuff done during test day, and it never happens, whether we're in person or not. So, all right, so what we're gonna do is we're gonna do the right and the left-hand limit here. So and then the less than is always left, and greater than is always right. So we have, and I'm going to write out my limit notation. I need to see this. So the limit as x approaches -1 from the left of, and I'm just going to go ahead and put that function in there, 2 to the negative x, not the -1, 2 to the negative x. And I'm going to go ahead and plug my -1 in. So I've got 2 to the -1, double negative goes positive. My answer is 2. Okay. Now we're going to do the limit as x approaches -1 from the right, which means I'm using the bottom branch. So I'm going to use x plus 3. I'm going to plug in the -1. So -1 plus 3 equals 2. Okay. I notice that they're the same. So I need to write a statement that says that they're the same. So this is acting sort of what we have to do for your response type problem. I put way too many humps in my M, I'm sorry. So limit as x approaches -1, and then you name the function f of x equals 2. I need to see all 3 of those for the points on the first problem. Okay. Then the second part of the problem says continuous. So this is going to be what we have to state for the continuous part of the problem. I would start by making the statement that you know that, and I know this is repetitive, but you're going to make this statement. Okay. And you guys, for me, I would highly recommend just write this one on the paper and make sure your paper scans. Okay. I wouldn't try typing. It was the people who did try typing, they tried their best, but it wasn't typing in very well. And I'm not sure I'm picking the right problem yet to get it typed in for you well. I'm not sure if they have one that you can mix regular text with the math type. I'll look for it, but it was not going well. All right, then I want to see, we have to evaluate. So that was step 1, was showing the limit exists. Step 2 is showing that f of whatever the value is exists, and the value should be whatever is here. There was a weird e in it. That was a typo. It was not generating the question the way it should have been. The system wasn't. So if it's not the value where it's doing the split on the piecewise, that's what it should be. Email, text me through or let me know through the chat that there's something wrong there if something's not going right. Because it's an equals to, I'm using the bottom branch. And yes, we've already done the calculation. Yes, you're going to show me the calculation again. So it's going to be 2. Now my third thing was I have to show that the limit is equal to this. And I actually need to make that statement. So the limit as x approaches -1 of f of x equals f of -1. Okay. And then finally, I'm going to make a conclusion. Therefore, you are allowed to use those 3 dots. That's okay. That's a standard mathematical abbreviation. Because again, mathematicians can't spell and they're lazy, so we can't spell, therefore we use the 3 dots. So therefore, f of x is continuous. Continuous, please write out the word, even if you spell it wrong. Okay, I'll leave it there for a few seconds, and then I'm going to have you try one on your own. Okay, I'm going to put it up there to try. The BC kids in this second period are texting me right now saying I marked one of the videos the wrong way. So I'm going to fix that for them. Speaking of double duty, everybody take a minute, and I want you to try this one. I'm going to ask you some questions about it in the chat once you're done. So I want you to find the limit and then determine the continuity. Yes, it should be continuous, so you need to go through all of those steps. I'm going to give you 2 full minutes to do that practice right now, and I'm not going to talk. Okay, we ready? So tell me in the chat, let me know you're there. Let me know I'm not just talking to dots. Tell me in the chat, what did you get for your limit? Okay, you should be limit as x is approaching 2. So what did you get? I just need the number that you got as your overall. All right, I'm seeing a lot of 4s. Okay, that's good. I'm not seeing everybody answering, so I am going to quickly go over it, but I'm not going to go I'm going to go really fast, okay, because I want to make sure we get in everything. Okay, so I am plugging my 2 into those functions, right? And I have the one from the left is the less than, one from the right is the greater than. So I've got 8 minus 2 squared. 2 squared is 4, and then I've got 4. All right, and then from the right side, I've got 6 minus 2, which is 4. So we have to make our statement that the limit, if you want to put little therefores in front, limit as x approaches 2 of f of x equals 4. That was the first part. Okay. So then we have to show continuity. All right, so the first thing you do is you restate that the limit as x approaches 2 of f of x equals 4. That's proving that the limit exists. The next thing you're going to do is evaluate for f of 2. So what branch do I go into, the top branch or the bottom branch of my piecewise for f of 2? Tell me. There we go. Good. Bottom branch. Good job. All right. So if you hear me ask a question, it's not that I sometimes forget to say, tell me in the chat. Just put it in the chat, right? That's you being able to interact with the lesson. Okay. You're kind of giving me some information that you're there and you're thinking about it. Even if you're not in the chat, you should be thinking through it in your head as I'm asking the question, even if we were in class, because I know not everybody answers in class either, but as I ask the question, you should be answering it in your head. That's kind of self-talking to yourself, okay? We all do it. It's not weird. Okay, let's go ahead. We're plugging into here, and yes, you've shown it to me already that it's 4. And then you're going to write the statement, the limit as x approaches 2 of f of x equals f of 2. And then I didn't need the therefore yet, right? And then you're going to tell me, therefore, f of x is continuous. Okay? Good? Some of you tried to put IVT on this one. This one was not an IVT problem. It was a continuity problem. Okay, the IVT, it was a multiple choice. I don't have any examples of that in here. It is in the video that I'm going to be putting up later this afternoon. We talked about it this morning. Okay, let's talk vertical asymptotes. Okay, so there's two things that happen here. When I have vertical asymptotes, I know that I'm going to have to factor, right? So we got to be able to see the factoring piece. Well, let's just do it. So let's do some factoring. So what kind of factoring am I going to need for both the top and the bottom? Tell me in the chat, please. Either we're factoring or it's delayed or we don't know. Okay, I'm going to go ahead and answer my own question. We do need a magic X in a box. If you are having trouble with this type of factoring, you need to go to my YouTube channel, okay? Go to the Algebra 2 trig and its topic. I believe I did it somewhere in 4.1, okay? That's what I taught them this week. So there's a lot of stuff out there on factoring now. Okay, there was stuff out there before, but if you want to see the way I do it with the magic X in the box, it's in topic 4.1. It's probably 2 or 3 videos into that. Okay, so find that playlist. All right, so I'm going to multiply my first and my third together, so I'd get negative 24. And then in the bottom, I put a 5. I'm going to do this fast. Okay, so I need two numbers that multiply to negative 24 and add to 5. Tell me in the chat what two numbers multiply to negative 24 and add to 5. Okay, so Sach is telling me 8 and negative 3. Lots of 8s and negative 3s. Okay, here's the catch. I have a leading coefficient. If you were in my class last year, we learned about the box. This is also called the area model. Okay, that's the fancy mathematical term for it that they've come up with since I started teaching this 20 years ago. This is the way I choose to do it. You don't have to do it this way. There's another, if you search, I think it's 4 ways to factor quadratic. If you search that one, there's an Asian gentleman that shows you 4 different ways to factor a quadratic equation. So you're welcome to use any of his methods. I use the box. Okay, but that one's on YouTube too. Okay, all right. So you just have to be able to get it factored. All right, well every time. I'm going to take that 3, put it in the top left-hand corner, and the negative 8 and put it in the bottom right. And then I'm going to take my numbers from my magic X and stick it in there. So 8x and negative 3x. I ask myself, what times what equals 3, or what are my factors of 3? I know it's 3 and 1. So my 3 is going to go on the top. My 1's going to go on the side because 3 divides 3. It does not divide 8. Now I'm going to do that division. 1x divided by 8x is 8. 3x divided by negative 3x is negative 1, and negative 1 times 8 is negative 8. I don't know why I picked one with a leading coefficient today, but I did. All right, so I know that my factors are 3x plus 8 times x minus 1, which we really haven't done any calculus yet, right? We're just doing algebra right now. All right, I need to do another magic X for the denominator. So you're going to help me out with that one again. Okay, so magic X for the denominator, I need 2 numbers that multiply to positive 16 and add to negative 10. Help me out in the chat. 2 numbers that add to positive 16 and multiply to positive 16 and add to negative 10. I can't talk. Uh, 8 and 2. Oh, negative 8 and negative 2. Okay, I'm seeing a lot more negatives in there because we need to add to negative 10. What am I going to have to do next? Do I need a box? Yes or no? Do I need a box? We do. Am I bringing back some memories of last year? This lesson is, this is the first time I've hit a lesson like this week where I'm like, oh, I wish I was in my classroom, because it's so much better in my classroom when I do this lesson. All right, because of the responses I get from you guys. All right, so top left-hand corner of that box is going to be the 2x squared. Bottom right is the 8, and the reason we're using the box is because we have a leading coefficient. And then I've got negative 8x and negative 2x. Two numbers that multiply to 2 would be 2 and 1. According to my box, I could have done something else with this actually. It doesn't really matter where I put the 2. I'm going to choose to put it on the top because I messed up on something, because I should have taken out a greatest common factor, but we'll do it in a minute. So I asked myself, how many times does 1x divide negative 8x? It goes in there negative 8 times. How many times does 2x divide negative 2x? It goes in negative 1. Negative 1 times negative 8 is 8. But do you see how I ended up with this here has a 2 in it? I should factor that 2 out. So I'm dividing that out. So I should have gotten this in my denominator. So 2 times x minus 4 times x minus 1. All right. Now let's do the somewhat calculus piece. It's actually still really algebra, but we've been using it in calculus. What happens when I cancel? What's that called? Tell me in the chat. It is, in fact, a whole. Good. Is a whole something that's removable or non-removable? Damien went for the removable discontinuity. Good, 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 good. Okay, so a whole is removable. So really I have a whole at x equals 1, right? Because we set this equal to 0 in our heads and we move the 1 over. All right, so what's left behind? The 3x plus 8 over 2x minus 4. What's left behind in the denominator, not the coefficient, just with the variable, I set that equal to 0. And that becomes my vertical asymptote. So my vertical asymptote is at x equals 4. And a vertical asymptote, remember, is non-removable. Okay? All right, let's take a look at another one together. And then I'm going to have you try one on your own. So that's our next one there. All right, my factoring is a little bit different this time. How do I factor my numerator? What kind of factoring do I need to do? It's got a special name. Who remembers? Nice job, you guys. Difference of squares. Okay, so I can take the shortcut. Square root of x squared is x. Square root of 16 is 4. 1 a plus, 1 a minus. All right, look at the denominator. What kind of factoring am I going to have to use there? It's not difference of squares. It's not a trinomial. What do I have to look for first? What do I always look for first when I factor? Good job. We're going to look for a greatest common factor. Excellent. My greatest common factor in this case, what divides into both of them, is 3. So when I divide by 3, I get x, and I divide by 3 and I get minus 4. All right, it cancels again. So I know that it didn't ask me for this, but I know that that means there's a non-removable, or there's a removable whole at 4. And look at what I'm left behind with. I'm left behind with 4x over 3. So, is there a vertical asymptote? Yes or no? Tell me in the chat. What do you think? Is there a vertical asymptote? Good job. There isn't one, right? Because there's no variable left in the denominator. So because there's no variable, okay, there's no vertical asymptote. And I'm totally abbreviating vertical asymptote. No variable in denominator. Okay. You're going to practice a couple of different types of factoring here. So I'm going to give you that one. I'm going to give you 2 minutes. I want you to factor it. There's like 3 different types of factoring kind of mixed in there, even though there's only 2 problems. And then I want you to find your vertical asymptotes. All right, so I'm going to be quiet for 2 whole minutes. You guys work on that one. Okay. I'm starting to do a little bit of my factoring. Let's see if we're matching. So I pulled out a greatest common factor of x squared minus 64. And then I did a magic x in the denominator of x, 8, and I got x minus 8 and x minus 9. What am I still missing here? What did I not finish with my factoring? Brianna's saying square root, so it does have something to do with the square root. What's this right here? What's this called? What kind of factoring is that? There we go. We got to do difference of squares again, right? So I'm going to take the square root of x squared, which is x, and the square root of 64, which is 8. Make one a plus and one a minus, and that was good because yay, we get to cross stuff out, and we love crossing things out in math. That means we know we have a whole at x equals 8. So I am left behind with 2x plus 8 over x minus 9. All right, so tell me in the chat, what did you get for your vertical asymptote? I like the 9. Oh, I like the x equals 9s better. Okay, it should be more than just a number. So it should be x equals 9. I think that on the test, oh no, I did on the test. I remember I did put an x equals or a y equals. Sometimes if I do reformat the test a little bit, sometimes on the test I've been doing x equals and then I just leave you a box. So yes, your 9 would be correct. But make sure that it says that. And the reason I'm doing that is because when to get it to auto grade the right way, it's easier if I type that part and you guys just type the number, because the answers I get for this part from you guys are terrible. So they're all over the place and too many of them to figure out how to put those in, all of those in to get it to grade automatically. All right, here we go. We are supposed to determine the equations for each horizontal asymptote. And the horizontal asymptote and the limit as we approach infinity are one in the same. So notice it says we're supposed to show our limits. So really what I am doing is I am going to find the limit as x is approaching infinity of 2x squared minus 3x plus 5 over x squared plus 1. Okay? All right, so let's talk really quickly. We're going to bird walk a little bit and make a side note on what happens with the exponents on these, because these are the ones where I need to look at the exponents. So I'm going to put some notes off to the side here. If my exponent on the top is bigger, I know that my y equals or my limit goes to infinity, right? That would mean that I have like x squared over x, so I have, it's getting giant and less giant. So the more the giant is on the top, I know it goes to infinity. Exponent on the bottom is bigger. So let's look at that. That would be x over x squared, meaning it's going to be huge down here and not so huge up here. Okay, it'd be like 1 or something up there. That means that it's going to 0 if I divide a small number by a giant number. If the exponents are equal, then you look at the coefficients in front of highest exponent. Okay, so let's do that. So looking at the problem we currently have, is the top bigger, the bottom bigger, or are they equal? Tell me in the chat. All right, I'm seeing a bunch of equals. Good. So that means I am only looking at the exponents in front of the highest exponent, and you could get fooled by this one. Sometimes they'll move the highest exponent backwards somewhere, so we'll just watch, make sure you have the highest. So it looks like in this case I would be looking at 2 over 1. So my limit would be 2. My horizontal asymptote would be y equals 2. So if they ask for horizontal asymptote, that's what you would give them. Okay, let's look at the next one. So the next one is this. I get f of x equals x over x squared minus 1. So I am going to go ahead and try to use my limit to find it. So the limit as x approaches infinity of x over x squared minus 1. So on this one, help me out in the chat, and everybody can answer this. Let me know you're paying attention. Is my exponent in the top bigger, the bottom bigger, or are they equal? Good job. The bottom is bigger, okay? So if the bottom is bigger, that means, and if I'm putting in infinity, that's basically insignificant. So I'm really kind of looking at x over x squared, or 1 over x, which means when I put infinity into that, I'm getting a small number divided by a giant number. So this is equal to 0, meaning my horizontal asymptote is y equals 0. Okay. I don't want you to let this one fool you. Okay, I want you to take a look at it for a minute. Okay, now that you've looked at it for a minute, we are going to try to solve it with our limits. If we're going to put infinity in here, these guys are going to be totally insignificant, right? So tell me, in the chat, what do you think? Is the exponent in the top bigger or the bottom bigger? It is the bottom again, and that's right, because basically we would kind of cancel those. We'd end up with the square root of x to the 4th over x cubed, which would be x squared over x cubed. So our bottom is still bigger. All right, so when the bottom is bigger, we know that that one approaches infinity. So really on this one, we wouldn't have, I am sorry, it does not approach infinity. What are we thinking, Mrs. Ballard? It approaches 0. So we would say that our horizontal asymptote is y equals 0. Okay, I'm going to give you one. I want you to try it on your own. Okay, so take that one right there. Try it on your own. Go to all the way to finding the horizontal asymptote. All right, tell me in the chat. Don't forget x equals or y equals. What's the horizontal asymptote? All right, I'm seeing a bunch of y equals 2's. I'm going to go ahead and I'm going to look at it with you guys. So I know that it's going to infinity, which means I really want my highest exponent. I'm going to kind of ignore those two. So I'm really looking at 2x over the square root of x squared. I know the square root of x squared is just going to be x, which means my exponents are the same. So I am looking at the coefficients in front, which is there's an invisible one on the bottom. So my limit is equal to 2, which means my horizontal asymptote is at y equals 2. Okay? All right, we have one more type here that we're going to look at a little bit. This one is simply, it's basically doing the same thing as the horizontal asymptote. We're looking at our limits approach infinity. So I want you to look at that one really quick and try it. You're going to tell me in a couple seconds here, not yet. Try that one. See if you can get the limit on it. All right. What is the limit on that? Put it in the chat. And it's not an x equals or a y equals. This is just a number because it starts with the limit notation. It doesn't say asymptote. Okay, so you're correctly noticing that our exponents are the same, which means that I'm just going to look at the coefficients in front. And actually, I'm seeing a couple of correct answers in the chat there. 2/4, perfectly legitimate, and that's a correct answer on the AP test. You don't need to reduce. I am also seeing the reduced version 1/2, so I would take both answers. Okay. All right, looking at the next one here. So everybody take a minute. Don't put it in the chat yet. I want everybody to take a minute and figure that one out. What is the limit there as we're going to negative infinity? Okay, now that you've had a little bit of think time, tell me in the chat, what do we think we get as the limit on that one? Put it in the chat. I like the 0, okay? So I'm thinking, okay, it goes to infinity, those are insignificant. I have 2x over 6x to the 12th. I don't really care about the coefficients either. I'm mostly looking at these. I notice the bottom is bigger, right? So if the bottom is bigger, that means it grows faster, which means that it goes to 0. So 0 was correct. Good job. All right. Here's another one. So I only have, oh, I've got more than that, don't I? Let's see where we're at. Got 4 minutes. Okay, try that one. Okay, tell me in the chat, what do you think the limit is? I think some of you were waiting for me to ask, weren't you? And you just hit enter as soon as I asked. Okay, so it is in fact infinity because my numerator is bigger than my denominator, right? Exponent, so I'm going to say that that one's infinity. Good job. I do have another example here with a square root in it. I think I videoed yesterday's, so we're going to let yesterday's video help you with that one if you want to see it. I want to make sure we cover one of these, though, before I let you guys go. And we probably need a Halloween joke, right? So we'll do this one, and then we'll do a Halloween joke. So we're supposed to find the constant a which makes the function continuous. Be sure to justify your solution using proper notation. If it's continuous, we know that the right and the left-hand limits are going to be equal. So that's where we start with this one. So the limit as x approaches a, now be careful. Look at, they reversed this. This is technically the right because it's the, no, it's not. They didn't on this one. Was it the other? I think there was another one they had reversed. It's fine. It is, no, it isn't. It is reversed on this one. This is the right because that's the greater than, and this is the left because that's the less than. It doesn't super matter on this, but just trying to be conscious of what's going on here. So I'm going to go from the right first because that's what I have in my top branch. So 9 minus x squared. And then I'm going to set that equal to the limit as x approaches 2 from the left of ax. So our goal is to try to solve for that a. If it's continuous at that, if we're trying to show continuity at that point, I should be able to plug that value in that they give us. So 9 minus 2 squared equals a times 2. Well, 2 squared is 4, and 9 minus 4 is 5. And then I am going to divide by the 2. So the a value that would make that continuous is 5/2. Okay, that's what I'm going to have time for today. I am going to send you a link in a few minutes here if you'd like to join third period. I'm going to put it out to third period too. And if you have done any of the progress checks, I'm not going to be formal about it, but I will answer questions on some of the progress checks, even though I know we're not doing that till next Thursday. It's good to hopefully you've seen some of it. So I will send that link out here in a few minutes. I need to take a 5-minute break and do that once class is over here officially. I'm going to hit stop recording.